I'm going to start 7.3 with a little bit of vocabulary. It's not terribly important that you have a great mastery of this vocabulary, but I'm going to be using it, so it's helpful if you kind of know what these words mean when I say them. So an experiment is kind of the general thing that we're going to be finding a probability of. It needs to have an activity or an occurrence with an observable result, so whatever. A repetition of an experiment is called a trial. So if you're doing something again and again, we call each time we do that something, we call that a trial. So for instance, if you're flipping a coin, if you're flipping it 6 times, you might say that you have 6 trials. All right. Each possible result of a trial is called an outcome. So the first time you flip the coin, it's a heads. The second time you flip the coin, it's a tails. Those are each of the individual outcomes. The set of all possible outcomes for an experiment is called the sample space. So in the example of flipping a coin, if that's your entire experiment, your sample space would consist of heads or tails. If you're talking about an experiment where you flip a coin or flip 3 different coins, you might have a little bit more complicated sample space. It might be heads, 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 tails, for each of your individual coins. And then, heads, tails, heads, and heads, tails, tails, and, I'm not going to go through all the list there, but just to give you an idea, the sample space is the set of all possible outcomes. In general, it's best to use outcomes that are all equally likely. So, in the example where I was talking about flipping a coin, you wouldn't want to say getting 2 heads versus getting 1 heads versus getting 3, or getting 0, 1, 2, or 3 heads, because these are all not they don't have the same probabilities. You're more likely to get 0 or 2 heads than you are to get 3, or sorry, you're more likely to get 1 or 2 heads than you are to get 0 or 3. All right, so let's see. Some sample spaces that would be good. If you roll a 6-sided die, then your sample space very naturally would be the outcome of that die, a 1 through 6. If you flip a fair coin, I do specify a fair coin here, so it's 50% chance that comes up heads, 50% tails. By and large, unless we specify that it's an unfair coin, we're assuming that you're just as likely to get heads as you are tails. Alright, so if you flip a coin, flip a die and flip a die. If you roll a die and flip a coin, then your sample space would be something like this. You need to take both the outcome of your heads, or the outcome of your coin, and the outcome of your die together. So you could say you get a heads with a 1, a heads with a 2, heads with a 3, heads with a 4, all the way up through heads with a 6, and then you could go tails with 1, tails 2, tails, and so on. You wouldn't want to say your sample space is getting a heads or tails and then a 1 through 6, because that doesn't say everything that happened. Alright, so an event is what we get when we take a subset, when we take a portion of that sample space. So for instance, if this is our sample space, and let's say I took these outcomes right there, I could call that an event. This, I might call the event E. The event E is getting heads with a 5 or greater, or getting a tails with 4 or lower. That might be the particular event you're looking for. I don't know why you'd want to do that necessarily, but we would call that subset of the sample space an event. Another example, if you're rolling a 6-sided die, the event that you get a 3 or greater would be the outcomes where you get a 3 or greater, a 3, 4, 5, or 6.